Okay, this is a very brief video or not video, but presentation to talk about half-life, the concept of half-life as it applies to our class. Okay, the concept of nuclear decay is relatively easy. So if I have a radioactive isotope and I know the original amount, it may be in percent or perhaps you know the original gram amount. After one half-life, I'm going to have half of that amount left. So if this was something like carbon 14, its half-life is somewhere around 6,000 years, so it would take 6,000 years to reach the half-life. And if I waited for another 6,000 years, I would have half of that amount. So it keeps on going down by half, and the time interval is going to remain constant. So I can keep on going on and on and on forever, just cutting this number in half. We can also plot this on a graph. So I've plotted the half-life data for the first 6 half-lives of an arbitrary isotope. And if this was something like carbon, well, let's go with something I know. I know that iodine-131 has a half-life of about 8 days. And so each of these intervals, the time half-lives, would be 8 days. So if I went all the way out to 6 half-lives, that would cover a span of 48 days. And iodine-131 is an isotope that's administered for hyperthyroidism. So if your thyroid gland is overactive, then what often is done is to administer medicine that contains iodine-131, which is taken up by the thyroid gland. And we might want to know when we're going to reach 30% of the original amount. And this is as easy as just going over to the graph and finding about where 30% is, reading across to the curve, and then reading down. And if I was getting down to 30% of my original amount, it looks like that's going to be, if I estimate that, maybe about 1.8 half-lives. So a little shorter than the 2 half-lives, which would be 16 days. This would be 3/4 of the way, maybe. So maybe somewhere on the order of 11 days. So is that right? No, it's more than half. So 3/4 would be 6 days. So that'd be about 14 days there. So don't pay attention to me. That looks like it's about 1.75 to 1.8 half-lives. So that would be in the neighborhood of about 14 days. So 1.75 times 8 days. So that looks like what we have there. Okay. On the other hand, maybe we want to know how much of our iodine-131 remains after 3.5 half-lives. So basically I go out to my half-life, and 3.5, I just go up from there and then read over, and it looks like that it's slightly less than half of the way to 20%. So at 3.5 half-lives, I might expect that maybe 8% of the amount that we started with remains. And for our purposes, we just have to be able to read these type of curves and estimate the amounts that we have, whether we're starting with half-lives or percentage, and find the corresponding amounts. If you go on to take Gen Chem, we'll talk about a mathematical relationship that allows you to calculate the amount remaining at any given time between the starting point and wherever you choose to end. And that's about it for radioactive decay.